Hello students, and welcome back to class. In a previous assignment, we worked on evaluating algebraic expressions. This is an important topic that will pop up often over the course of this semester. So let's practice it a little more today. The instructions are to evaluate each expression for x equal 2, y equal 5, z equal 3. I made a little note of PEMDAS here because we'll be using that on some of these problems. When you do these problems on your notebook paper, I'd like you to write the problem down this way, then copy it, putting parentheses where the variables are. So you copy down 3x squared plus 2x minus 5. And then you rewrite it as 3x squared plus 2x minus 5. But now I've got room to plug in for the x's. And I know in the instructions, I'm told that all x's become 2's. So x becomes 2 and x becomes 2. Now to simplify, we'll think PEMDAS. There are no grouping symbols, but there is an exponent. Let's take care of the exponent first. 2 squared, 2 times 2 is 4. Now copy, and copy, and copy. After exponents come multiplications and divisions. And if you've got more than one multiplication and division, go left to right. 3 times 4 is 12. 2 times 2 is 4. Now add and subtract. Go left to right. 12 plus 4 is 16. And 16 minus 5 is 11. Circle that answer. That looks great. Here comes number 2. For number 2, I'll copy the problem on my notebook paper this way, then rewrite it, and everywhere there's a variable, a set of parentheses to fill in. So x times z minus 1, quantity to the third power, becomes x times z minus 1, quantity to the third power. Now in these problems, x is 2, z is 3, and now we're ready to evaluate. Think PEMDAS. Are there grouping symbols? Parentheses? There are. Let's work inside that set of parentheses first. Inside of the set of parentheses, there's multiplication and subtraction. I know multiplication happens before subtraction. So multiply 2 times 3. Let's stay inside the grouping symbols and subtract 6 minus 1. Finally, all that's left is to take 5 to the third power. 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. See how my work kind of takes on the shape of a triangle? That's ideal. You want to write the problem down, fill in the x, y's, and z's, work your problem down the page. No equal signs if possible. That's the way to show your work. Let's try 2 more examples. For number 3, copy the problem down as it appears in your book, and then rewrite it as 3x, big set of parentheses, y plus z. Now we'll fill in where x is 2, y is 5, z is 3. Let's think PEMDAS. Are there parentheses? Yes. Let's work inside of those parentheses first. I'll copy the rest. Inside of the parentheses, I'm adding. 5 plus 3, that's 8. Now all that's left is to multiply. And if I'm only multiplying, I'll go left to right. 3 times 2 is 6. 6 times 8 is 48. And circle. Good. See how that works? Kind of makes that nice triangle shape. No equal signs, that's the goal. Here comes number 4. Now for number 4, think of the division bar as a grouping symbol. There's a top group and a bottom group. The top group is 7x plus 2y. The bottom group is 3x. In these problems, the x's are 2's. The y is a 5. I'll do the top group first. In the top group, I've got multiply, add, multiply. Multiply happens before add. So multiply the 7 and the 2, multiply the 2 and the 5. 7 times 2 is 14. 2 times 5 is 10. Let's go ahead and finish the top group. 14 plus 10 is 24. In the bottom group, all I have is 3 times 2, which is 6. Bring that 6 along. Finally, 24 divided by 6, that's 4, and I'll circle that as my final answer. Now, I know I like to say my work should end up in a triangle. When I've got fraction problems, my work sometimes gets kind of messy. That's okay. Keep it this way whenever you can. We go into these understanding that sometimes your work just isn't going to fit into a nice triangular shape. I sure have enjoyed working with you today. Do lots of homework. Get it all turned in. I'll see you later on this week.